Okay, we're just going to roll through just some practice problems here to practice. Okay, there's two types, one of which is going to be just dealing with a basic of, hey, this is a zero, hey, this is, your power, whatever, how do you write your answer? And then the other one is going to be, hey, here is a function here, okay? We want you to find the zeros, what's the multiplicity, does it cross or touch, what would the end behavior look like, okay? So just four problems here that I want to run through with you guys. So this first one here is pretty straightforward, okay? And this first one follows the rule that says that if you get that x equals r, then a factor of that is x minus r is going to be one of the factors, okay? So what this is going to tell us, important information, is it tells us that this is a degree 3, okay? All the coefficients are real numbers, and it has at least the zeros of 2, 4, and 0, okay? So since it says that it has the zeros of 2, 4, and 0, that means that when I solve this, I got x equals 2, I got x equals 4, and I got x equals 0, okay? So there's all my x's. Well, this is telling me then that I can write it in this form here. Okay, so to do that, I could subtract 2, subtract 2, subtract 4, subtract 4. I don't really need to subtract anything. I guess technically I could subtract 0. Okay, and when I do that, I end up with x minus 2 equals 0. I end up with x minus 4 equals 0. And I end up with x minus 0 equals 0. So basically what this is doing is this is telling me that my factors are x minus 0, x minus 2, and x minus 4. Okay? Is that going to be a degree 3? Yes, because I have 3 x's there all to the first power. Okay? The only other thing is, what is x minus 0? Well, x minus 0 would just be an x, so a better way to write this would be x, x minus 2, x minus 4. So there's the function that they asked us to create. Okay? All right, let's do another example then. Write a polynomial function of degree 3, okay, whose coefficients are real numbers and has the 0 of negative 3 and 1. Okay, so same process on this. I had that x equaled negative 3 and I had that x equals 1. Okay, so this time when I did it, I would need to add 3 to get it over, still subtract 1. So I end up with x plus 3 equals 0. And I end up with x minus 1 equals 0. So my two factors are x minus 1 and x plus 3. Am I done? Is this a degree 3? Well, no. Right now I have an x to the first power and an x to the first power. That just gives me an x squared. Okay? So it looks like up here I might have had a little bit of a typo because this also says that negative 3 has a multiplicity, and I left it blank. So negative 3 has a multiplicity. Well, in order for this to be a degree 3, it would have a multiplicity of 2. Okay? So instead of this just being an x plus 3, since it's a multiplicity of 2, I would need that to be an x plus 3 squared. Okay? So nothing too bad on that one there. All right, let's scroll down then for the other type of problems that we will see. Okay, first one here, I've got f of x equals negative x, x plus 2, and x minus 4 squared. Okay, so I need to work my way down through this. So the first part says I need to find the zeros. Well, when you find the zeros, remember, that's just when you set this whole function over here equal to 0. So if I do that, I would have negative x equals 0, x plus 2 equals 0, and x minus 4 equals 0. Okay, divide by negative 1, divide by negative 1, gives me x equals 0. So 0 is one of my zeros. Subtract 2, x equals negative 2. Negative 2 is another 0. Okay, add 4, x equals 4. 4 is another 0. So I have 0, negative 2, and 4. The next thing it wants to know is it wants to know what is the multiplicity of each of these zeros. Okay, well, for 0, the multiplicity would just be 1. So we have a 0 multiplicity 1. My negative 2 would be a multiplicity of 1. So I'd have negative 2 multiplicity 1. The last one I have is my 4, and 4 has a multiplicity of 2. Okay? And I got that just by that exponent there. Now it wants to know, tell whether the graph will cross or touch the x-axis. Well, this graph is going to cross at, remember it crosses at any of these places where they are odd. So it will cross at 0 and negative 2 because those have odd multiplicities. It will touch at 4 because 4 has an even multiplicity. Okay, so it's going to cross at 0 and at negative 2, but it will simply touch at 4. Okay, and then the last thing it says is, what will the end behavior of this function look like? Now, to find the end behavior, okay, I need to go through and I need to find my power function. So remember, for this, we're going to look at the first of each of these up here. So I have a negative x, and I have an x to the first power there, and I have an x squared. Okay, that first x is also next to the first power. So if I multiplied all these together, my power function for this is negative x to the fourth. Okay, so negative x to the fourth is my power function. So you can scroll back if you don't have these memorized yet. Okay, but what fits in for negative x to the fourth? Well, my n would be even, and then my a, the number in front, is negative. So I'm going to have that upside down parabola for my end behavior. So my end behavior here would be that upside down parabola. Okay, now, if you want to, and this is not required, but if you want to, you can draw a basic sketch of this now. You draw a point at negative 2, at 0, and at 4. I know that my end behavior starts down here and also finishes down here. So I'm going to come up, and I know that at 0 it crosses. I know that at negative 2 it crosses. And then I know that it touches at 4. So that's kind of a basic shape of what this function is going to end up looking like. Sorry, I'll scroll down so we can see it all. So that's kind of a basic shape of what that function is going to look like. Okay. This next one here, I want us to mark it out real quick, because another way that you will see all these functions written out is you will see them written out as f of x equals x to the fourth power plus 2x cubed plus, no, not plus, sorry, we'll go minus 3x squared. Okay, so the first step, write that down. Then the first step is they want to know what are the zeros of this function here. Well, to find the zeros, we would have to set this equals 0 equals x to the fourth plus 2x cubed minus 3x squared. And I would need to factor to find the zeros. So you're just going to go through your factoring steps here. So the first thing I do is I could pull out an x squared on this, which then leaves me an x squared plus 2x minus 3 inside the parentheses. Now I'd go 1 times negative 3. What are my factors of 3? That subtract to give me 2. Well, that would be 3 and 1. So I have x squared. And then this ends up factoring to an x plus 3 and an x minus 1. Okay, so I'm setting each of these to 0. 0 equals x squared, square root, square root. I get that x equals 0. 0 equals x plus 3. I get that x equals negative 3. 0 equals x minus 1. I get that x equals 1. So my zeros are negative 3, 0, and 1. Okay, so basically what I'm showing you guys is you may have to factor to solve some of these too. Okay, what is the multiplicity of each of these 0? Well, negative 3 would have a multiplicity of 1. Okay. Next, I would have 0 with a multiplicity of, so 0 was right here. What's my multiplicity? Well, that would be a multiplicity of 2. And then the last one I have is 1, and 1 has a multiplicity of 1. So just looking at the exponents to find those multiplicities there. Okay, then you need to know if it crosses or touches. Well, this graph would cross at all of your odd multiplicities. So it crosses at -3 and 1. Okay, and then it touches at my even, so it would touch at 0. Okay, now when you have them like this where you have to factor, it's more difficult to find the zeros and the multiplicities, but it is much easier to find the power function, because if it's all multiplied out, the power function is just simply your first term there. Okay, so it wants to know what would the end behavior of this function look like. Well, my power function is just x to the 4th, so it's an even exponent, but this time it's positive in the front, so my end behavior would just simply be that shape there. Okay, so we will go through in class and we will be practicing each of these sets